Hello, this is Roger Miller. A couple of months ago, I created some videos trying to go through the details about the control mass variation and some of the different ideas around that. But in doing that, I actually went back and was thinking, let's just kind of take a complete step back and actually show a principle. Actually had these 3D printed to actually kind of provide a better picture's worth 1,000 words kind of a situation. So we'll see how that works. So here's the original concept. We've got 5 gears, all the same size, same number of teeth. One in the center that's actually locked, and we have these other ones that are actually spinning around it. And the thought process here is, as we're going back talking about the original from March of 1990s, the idea of the 1990. The idea was that a fan was spinning, if it could get it out of balance, that it could actually create motion. And this is one of the original, or this is one of the concepts that led from that. And the idea here is that you got there's actually these weights that are on here, on each one, out on one of the teeth. And they're positioned to the point where when it's like right here, the mass, we got these two down here, and these two right here, so that the center of mass is actually off the center. So the idea is that if this spins, that they keep on going with that. But one of the other things that actually comes across here is, if you watch, like right here, in order for this gear to go to this gear, the weight would actually travel this whole distance here, where for this gear to go to this gear, it basically just travels this distance right here. I'll show you an example of this, as you can see it. So as that one, it went to, if this one goes around, it goes a long distance. So one of the things that, so not only is it out of balance, but this actually leads into Einstein's special relativity, the 1 over the square root of 1 minus v squared over c squared. That as an object, as matter is moving, the faster it moves, the more energy it takes, more effort it takes to push on it. So, and basically, this velocity here, or speed here, is just the distance that it travels. So this distance is a lot smaller than this distance. So that means the speed that this is traveling is going to be greatly, I think it works up, I think I did the math, was 6 times faster to go from this distance to this distance. And so the speed is going to be 6 times over here than what is over here. And with Einstein's theory of relativity, the equation actually says that it's going to take not a lot, but if you can get some serious speeds going, relativistic speeds going, you can actually, the amount of mass over here is going to be actually greater. And if you do that, and it's pushing down, it's going to take more force pushing this down, what's going to end up happening is going to create an upward thrust. So that's that concept here in a nutshell. Got some other ideas, and actually I'm going to just continue right on going into the next one. So the idea here is, we got this right here, and I think you can see this, maybe not so well, put it like that. So what we have here is, if an object is moving just this distance here, so if it's moving this 7 inches and then 7 inches back, it's exact same amount of effort it takes to push it. If this was flat, it would take it moving back and forth. However, if this was flat, I've got it so I can kind of demonstration here. However, if this spins, so the question comes into, how far did these individual pieces travel as it spins and moves down this way? Well, when it moves this, it's only 7 inches. But if you're rotating this 100 times, that distance is going to, the distance that any one tip travels is going to be a lot greater than just the 7 inches. So if you had it spinning going down and then solid coming up, spinning as it's going down, not spinning when it comes back up, spinning when it goes down, not spinning when it comes back up, technically you could actually create a propulsion system from that, because the mass of these things spinning actually creates a lot more. And how did I come up with this little gadget? In the mid-90s, 1990s, NASA published. There's some papers that was published actually talking about Voyager and Pioneer 10 and 11 and Voyager 1 and 2 were actually traveling slower or had some differences in their speeds that were not falling in line with what they're expecting. So I actually took a look at the design of those spacecraft, and one of the things that they did is they did away with gyroscopes, internal gyroscopes, and they decided to have the entire apparatus spin. So by having the entire apparatus spin as it's going through space would help it keep oriented so that it could point and communicate back with Earth. Problem is though is that spinning in space as it's moving through space at high speeds means that the mass calculation for this was not, they were not doing it correctly. That you had to consider Einstein's one over the square root of 1 minus v squared over c squared. Once you calculate that in there, I was able to come up with numbers that were getting in the ballpark of what they were looking for. Anyways, that was kind of an interesting time. Conversed back and forth a little bit with them. Basically, the last communication I had with them was when they called me Dr. Miller, and I said, no, this was just a hobby for me. After that, if you can imagine, they no longer had any more communications. So anyways, let's go to this last piece here. So this last piece, actually, we should probably set this up maybe a little bit. All right. Let me see if we can get this closer so we can actually see what's going on here. There we go. So what we have here is, this is actually using general relativity and not special relativity. So the idea here is I created these gears, and in each one of these gears is a magnet. And the magnets are all pointing the same way, so that they're actually, as the magnets come in here, it's north, south, so that they're attracting. So they're attracting. So the idea, it's just a very, why would anybody want to do something like this? Well, interesting things happen. Let me go ahead and just show you. This one actually have a motor hooked up to it. Whoop. It needs a little bit more. So what, right? Well, the so what comes in is still the same thing with general relativity. Actually talks about the attraction, but the problem or the opportunity here is the fact that these magnets are being attracted, but at any point, so they're actually moving. So what this one's now looks like is it's seeing this one and this one. But if this is moving like that toward it, this is actually this one would actually appear to be further away, appear to be closer this way than what this one is, because it's actually traveling toward it. So as it's traveling toward it, it's going to actually see more. So if going through this, because this is spinning at high speeds, it would actually be able to be more attracted. This would be more attracted to this one, and this would be more attracted to this one. This would be more attracted to this one than the one behind it. And if that's the case, you can actually create a motion by that way too, of actually getting it pulled, because the magnets are actually being pulled toward one side as opposed to back toward the other. So anyways, those are the three ideas. Just real quickly wanted to go through, make sure that they were on tape. I'm going to continue working on these. I am going to try to set this up in water. Actually create a flotation device, set it up in water to actually see, if it moves. My other thing that I was really working on a lot with the Voyager 2 is that it may have to do the motion of us traveling through space, through the galaxy, and the Earth spinning, the Earth moving around the sun moving around the galaxy moving in the through the neighborhood. All those speeds, different speeds and velocities may actually add up, so that certain directions may be more beneficial for this process to work than the other. That was another concept that I had, was basically a cosmic brake, that there should be a way that you could actually create a cosmic brake by having objects spinning, would actually be more force going one direction than the other one, that would actually send you away. Good news for actually leaving the planet, not so good news for coming back, because once you put that brake on, there's no way to accelerate back. There's no, using that process, no way to accelerate back up. But if you do it going in the right direction, traveling at, using a cosmic brake would also, I think, be very beneficial for at least, seeing what's out there. All right, that's what I've got for today. Thank you so much for your time.